interesting point is Christian and I have actually been collaborating on doing some of the PDF work. I use his PDF tools to do my report tools. So I think we've been corresponding for like 7 or 8 years now, sometimes quite a bit. This is the first time we've met in person. So it's been a really interesting, process. So first of all, TRAX is the name of our ERP application. It's got some history to it. And the point of this talk is not for me to show you the application. What I wanted to do was cherry pick some interesting technical points to show you, but also to give you a bit of a perspective of working on a production system where there's history, there's legacy issues, there are real-world constraints as to what you can do and when, and it's a different kind of mindset than doing something that's just technically cool or technically interesting. I've been doing Smalltalk exclusively since 1993 for a living. I've been slinging code since then. So, I've had a chance to kind of develop some experience with this. Coming to these conferences is really invigorating for me because I love seeing some of the technical, interesting, cool things that people are working on and for the next generation. But I then have to translate that to working on applications. And I don't know if you're working in academia or if you're doing something or if you're strictly on, perhaps even on the bench side, and deep in the technical aspects of what Smalltalk is doing, you might not have an opportunity to be exposed to the application end of that process. So if you're doing something technically interesting, there's an end game to that, and that is for the application to be used, for someone to make use of that technology that you've developed. And that's the kind of stuff I'd like to show you. So we're a company of about 650 people. They're growing all the time. Of that, about 450 use the application. The scope of it is expected to grow, so more and more people will be using it. It involves sales, project management, accounting, so it does run the business. People use it all day, every day. And the cool part of the story for me personally is being that I'm a long-time Smalltalk developer and advocate of the system, run the Smalltalk user group and stuff. This was new development. This was a brand new application that was rolled out. Part of it was that we had a port fact client that had been in development prior to us working on this. And there was an interesting story for that. There was, the fact client had some architectural challenges, it didn't scale, had some code problems, but it was good enough to develop business rules. So the business side of it, and the people doing the development work, were able to have some communication about how the flow should work, what happens when you transform a number, what happens when you update something. And there was a perceived value in those business rules. So when we came to the point of wanting to deploy the application and look at it from a real-world scaling and flexibility point of view, there was a bit of a debate about whether we should replace or port. From a technical perspective, and strictly as someone looking at it as the internals being aware of all the code issues, for me it was self-evident that you replaced. But we're also dealing with business issues. We're dealing with business users who have to pay the bills. And from their perspective, they had spent, at that point, a couple of years working through business rules. And they were looking at this fact client saying, hold on, there's some value here. So there was a perception of value. And if we come forward and say, from a technical perspective, replace this because it has no value, then you're then asking for someone to fund this new development, and you've just said that the thing that they've worked on for the last few years had no value. So those are the kind of real-world decision points that you end up having to deal with when you're doing the application level of deploying, of developing Smalltalk work. And it's been an interesting process because we started doing the work in 2012. So we're 5 years into it now. We've been live since 2015. And we now have the benefit of hindsight. And the benefit of hindsight is self-evident that we would But that's not what you know at the time. You can't govern yourself with the benefit of hindsight because you don't know what you don't know at the time. So that was an interesting kind of evolution in kind of my perception of how we should work and you know what we should do and what technologies come in, and kind of making sure that the scope of your decision includes the business side, because somebody has to pay the bills. And the whole point of this application was to make our salespeople better, so they could make more money, so they could be more efficient and pay for an application. And that's a real world aspect of it. So let me jump into some of the technical things that we did along the way. So one of them was, hey, we had this fact client VisualWorks application, and we wanted to deploy it as a web application. What do you do? Do you rewrite all your views? We had something like 1,200 views to look at, and some were fairly complex and so on. So very early on, it became became evident that if we insisted on rewriting this, there would be a huge upfront effort, and that was a cost. So I looked at it and said, well, you know, it's not that hard to take a VisualWorks window spec and map it to Seaside, just by creating these internal Seaside components that they know how to render themselves. Yes?
Did you consider VisualWorks?
Did I consider? Yeah, well, yes. And yes, it didn't really work for the kind of things we wanted to do. We looked at it was a subset of supported window specs, and at that point, the fact client had already been built out. So for us to then go back and constrain the existing window specs to fit into what the VisualWorks support code would have worked on didn't really fit for us. The other part of it is that building Seaside components that you then render gives us additional value. So we were able to do things like I was able to give myself expanded inspectors on an input field that would then show me better state visualization of these results and show us our structure within the Seaside piece. All of that came from doing this translation and building Seaside widgets, components that we can then wire together. And that became convenient. So doing this, we just did a one-time pass, and you can see how like a VisualWorks layout would map to a Seaside layout. The downside of that is you're deploying a web application from fact client window definitions, and you can tell because they're rigid size, they don't resize, there's positioning issues. It works, but it's not optimal. But again, one of those pragmatic choices that we had to make. The other thing we did was, we built this thing in VisualWorks. We deployed our database. It was a fact client, it was VisualWorks talking to GemStone, and now we have this idea of wanting to add a browser to the mix. So how do we now deal with kind of the fact client content when we have multiple users in the mix? And we tried various things at the beginning. At one point, we had the idea of having one VisualWorks image per user, and you'd have session affinity to that image, and that would be your mechanism, and the faulting and all that would work. Then we were looking at what kind of scaling issues we'd have with that, and how we'd work. So our deployed model was to say, no, what we're going to do is use VisualWorks to serve Seaside, to serve the web content. And what we're going to do is pull just the data that we want to display into VisualWorks. We're not going to fault the objects, we're just going to get some content to display. And we package it up as XML in GemStone, pull it into VisualWorks, extract the data, and then put in the fields that we wanted to see. And that worked reasonably well. There were some nice benefits from doing it this way. One was when we did the remote perform, we designed it so that there was no need for any kind of session affinity on GemStone. It was a RESTful call from VisualWorks to GemStone. So all the information needed to make the change, including whatever were the pending updates, were included in that RESTful call. A nice little side effect of that is we could log that and we could replay it if we were debugging. So there's some nice unexpected side effects. There was a problem though. What happened was we kept challenges with XML. You can imagine what it takes to package up all the possibilities of what you want to have. So a little later, we changed that part of the interface to say, no, because we have some complexity that's challenging for us to package, let's change how we're doing this. And instead of having a remote perform, let's just build a string that we can make arbitrarily complex and evaluate it on GemStone. We can do that. It's Smalltalk. You can just say evaluate a string and it'll compile it, parse it, give you the result. And then for the result, build a string using kind of a canvas metaphor, the Seaside influence of painting content on an output field. And the result is a string that VisualWorks can evaluate. And then within the VisualWorks environment, you'd evaluate that, and then your data would be the thing you display. And our data would be structured in a bunch of data nodes that you how to display their labels and had additional state and so on. Worked reasonably well. And that's what is currently in production. This is our current production system. But there's a problem. We want more complexity. As the system evolves, more and more complexity, more interaction, more kind of a lively interface. So we moved on, and this is what we're currently testing, which is have GemStone be the thing that serves the Seaside content. The beauty of that is it eliminates the need to generate intermediate strings, eliminates the need for doing kind of remote evaluation, and by far, the biggest win is that we have an ability for Seaside to talk to the domain directly, which eliminates a whole layer of complexity when we want to get things that are more lively and have more kind of subtle feedback to the user. Yes?
We're talking about more complexity, but I think even quite simple things can be very complicated here, because the one thing that made me decide against an architecture like the one you showed just before is the example of a combo box, which does some complex search on the server, which is not only find me a substring of a choice that I sent you to the browser, but do some search on the server and give me the results of that search as a result of an AJAX callback.
Exactly right. We have so that was one of the examples we have. We have search. So as you key in fields, you get a selected list, and you can a list to select from. For us, each one of those is a round trip to the database and back, packaging a string, getting a result, showing the list.
Yeah.
It's so much easier to just talk to the domain directly, right? So that's our motivation to do this, is to reduce the overhead that we need to put in every time we want to do something new. And we're a real-world application. They're always asking for something new. Hence, that's our motivation to move to this kind of model. There's some interesting things that we can do with this. One of them is, how do you deploy this big an architectural change in a real-world application? Well, the cool thing is there's nothing to stop us from having both. We can have this interface and this interface at the same time. It's just GemStone responding to two different requests. And that's exactly what we're doing. So as we're testing this right now, users can log in through one URL, that is the VisualWorks web interface. They can log into another URL, which is the GemStone web interface, and they can use them at the same time. And that's going to be our mechanism for ensuring that everything's working correctly. We're scheduled to make the GS web interface available in production in about a week or two. And the plan is to have a bunch of users. They're going to try to do their job using this new interface. And if they run into a problem or some constraint that we missed, a subtle adjustment, we got 5 years of these little changes that they'll have to deal with, they can go use the old interface. Let us know, we change it, and we move on. I'd love to see any other technology pull this off. I mean, you get some Java people in here and show me how they do that. So there. One of the other things that we did, and which was interesting, was dealing with pending changes. So you make a few changes in your application, in your state, and you want the application to reflect those pending changes before you commit them, because you're still in the process of filling in fields and making value changes. And our application has some deep business rules. So you change some values, it cascades out, and they see the result of that change, and now they can make a decision as to whether or not they're going to save that change. Our mechanism for doing that is to hold, have each object hold its pending changes, and we're calling it a data wrapper. It's wrapping the updates that it does. So if you ask an object for its name, and that name had been modified, you would get the modified name. And we do this with the getters and setters hooking into the data wrapper mechanism. All those wrap changes are known to our change context. So we have an object that represents all pending changes and you as a user in that system. We leverage the fact that we have this update mechanism. So this mechanism is in there now. It was there from day one, and it's evolved a bit, but we leverage the fact that we have that to manage your interaction with the GemStone Seaside interface. So what happens is, if you've got a pending change, you've done your set, you've made a change, and now you're refreshing your view, so there's another rendering that's happening. So your Seaside environment now has to handle that request. What we do in our handler is we tell this context to go engage itself. The session knows the context that currently applies. So engaging means bind yourself as a data wrapper to the domain object that you represent. And now any message send to get values from those objects answers those pending updates. And that's our way of distinguishing your changes from my changes as they're happening before we commit. So that's our kind of session binding for it. That part's has worked fairly nicely for us. The PDF reports are something we needed ported to GemStone. So we were generating PDFs in VisualWorks, and that's what you saw Christian talking about. We do some things in addition to that. So the tool we use to generate our reports is our 4P report, which does the layout of a report, page breaks, tables, content, and so on. But we can do more. The data components that represent the parts of a report can have extensions to them. And one of the extensions that we've added to them is the ability to hold updates. So we can then take this intermediate structure, the thing that would be handed off to the PDF tool, and we wrote a Seaside renderer of that report. So before the PDF is generated, you can see how it looks in the view, and this is something to use all the time. In addition, we can make that editable. So we effectively have editable reports in the view that can make their changes, save the changes, push a button, and get the PDF for them. And that PDF is generated from that view. Those are screenshots of exactly the same thing. Works very nicely for them. I'm very happy with how that works. So we've taken that approach of them liking the way the PDF looks. The nice thing about the PDF reports, when they're rendered, is they're web-centric. They're not a port of a fat client view to the web. They're rendered in a way that looks correct on the browser. If you size your view, if you change it, the table sizes expand and contract. It takes the outer constraint and pushes them in, as opposed to the fat client model, which is the inner components kind of needing to push out on the content, because they're the ones that are fixed size, so they kind of govern the boundaries of your view. The reports, the layout of the report, because it was HTML-centric, sized accordingly. So we took that approach and said, well, wait a minute, now that we're able to talk to the domain directly, and we no longer need to package our content and such, why don't we take this report idea and make that model the model for all of our interfaces, the next generation of interfaces. Within our domain, our domain has metadata, so every attribute has policy information for it, so we know what type it is, we know if it's updatable, and so on. We take that metadata, and within this new UI environment, generate these part suffix methods, and part as an homage to my VA Smalltalk days, so I picked a name, I like that one. So those part methods, where we have something like a login ID part or first name part, are automatically generated in this layout class for a particular domain object by virtue of knowing the metadata for that. And now as a developer, you can say things like, I just want to show these 5 attributes. And that's all you have to write. And then the way it's rendered is by the part knowing how to render itself, knows how to give it a label, knows how it's updatable, whether it's a drop-down list, radio button, Boolean, and so on. And we can build up on that. And we can do more complex things, like in the second example, we have a nested table where rows can be expanded, the cells can be edited either directly or with flyover content, and all of that being done in a way that doesn't require the developer to do a lot of low-level Seaside coding. That was part of my motivation, to try to make it so that the person doing the domain roles isn't having to do, bit-level coding on Seaside. But if they need to, they can, so that they're not constrained by the tool that we have. And this is working out nicely. We're getting a lot of positive feedback for how this looks, especially things like that expanding subtree. We develop in VisualWorks, and we deploy in GemStone, so I don't know what kind of acronym that generates, but it'd be probably awkward to pronounce. The beauty of that is, as a developer, we're able to build an in-memory model to do our development. So we do the majority of our development without being connected to a database. And then when we push our code to the database, we have to go through the simple transformation rules that you're Christian talking about. We have a different mechanism for doing that, but it's still fun. There's not that many places where we need to change our code, because domain code, as you can imagine, is pretty generic. It's pretty generic Smalltalk code, and that just maps one-to-one. The places we need to do transformations tend to be the framework code and the policies and little things like that, and it's well contained for us. It also gives us an opportunity to run our S-unit tests. So we run our domain S-unit tests on the VisualWorks model. We're getting better at running on GemStone. It's just a little more work because you need to get yourself to a testable state in order to run that. And we also have an automated process where, because our code base that we're pushing into GemStone is stored in VisualWorks, we can automate the building of our +1 generation code base in GemStone. So we have Jenkins jobs that every morning take a production copy, restore production, apply the changes that we have published in store, and as we come in the morning, we have databases set up that are running with production data and our latest code, and that's what we continue to develop with and test. That's proven very handy. And then for running the tests, we have a base set of tests that we are obligated to confirm or clean before we publish, and they take about 10 minutes. That's not bad. We publish 3 to 4 times a day, so that's not that much of an overhead. We have a full set of tests that take about an hour or 2, and those are run every 2 hours in VisualWorks by Jenkins automatically. So that gives us feedback through the day if we publish something that caused a problem that we didn't get in our base set of tests. So developing VisualWorks works very nicely for us. And then for debugging, GemStone, that kind of stuff, having the GBS tools, a lot of debugging with it. It's just nice. Very productive. A couple of minor other points that we do. We need to have some kind of batch running mechanism. So we have one VisualWorks runtime image that's logged out of GemStone. It's our supervisor image. It's responsible for running schedule jobs, asynchronous things. So we have certain things like notifications. If you make a change and you want a user to be notified of that, I don't want your session, you as a user, to be the event that has to then do the sending of an email. Instead, what happens is you queue that as an action. Hey, this notification is going to be queued. And then the supervisor runs every minute or so, will say, what are the queued emails that can do that asynchronously? So it's our asynchronous management system. It does our backups, does our mark for collection, notifies us if there's a problem, has a heartbeat that runs, make sure everything's okay. And it's a Seaside app. So our interface with it is through Seaside. And we can do things like real-time monitoring. So we watch what our memory use is, how many users are on. So this is a screenshot from last week, I think Thursday or so, around noon, and you can see the growth of our user base. The multiple colors represent the web servers that we have deployed. So the way we our current architecture with VisualWorks as the Seaside server works is we have 6 Windows VMs, the hosts, each of which runs 8 VisualWorks images, which are managed, which are spawned through polycephaly, that end up being the Seaside servers that are then fronted by HA proxy. So we have session affinity from HA proxy to the individual VisualWorks image, and within that image there's 4 GemStone sessions. So as a user, you just use whatever the next available GemStone session is, and we typically run 2 to 3 users per image is kind of how the distribution works. So we have some have 0 and some have 2 or 3, so we're trying to even that out a little bit. One of the motivations we have for moving to GemStone is we now have one pool of web servers rather than these isolated pools. And you no longer have session affinity to your web server, and that'll help us even out some of the resource mapping that we do. And you can see some interesting things from that. The colors represent one web server, so visually it's not so bad. But you see how there's a plateau and it drops off for memory use? That's because with Seaside, it hooks into an event in order to release the memory. So you can kind of see as the day wore on, some of the machines weren't being, then finally someone logged into it and then it released the memory and went on. So you get to see these kind of recurring patterns in their use. For the GS web interface, we have something similar, and it shows us the commit record backlog at the top, because that's a more interesting number for us to know. And then VM percentage overrides, if we want to see overruns, if it gets like to 70 or 80%, I put them on the graph. Then the user's activity and performance are the same. The performance thing is a histogram. That just shows us how many of the events that occurred, how many were less than 5 milliseconds to evaluate, how many less than 100, how many less than 200. So it gives us a sense of where users see that performance mix. Works fairly well, and it's nice to have this. If there's a problem, it shows it fairly quickly. Love the real-time monitoring capability. And that's just using Google Charts. Works fairly well. That's it for stuff I wanted to show you. Are there any questions?
Can you tell us a little bit about the transition for the users from their perspective when they have to switch from fat client to a web-based interface? How did you decide where to do the breaks between the old interface and new web-based interfaces in the browser? Did that cause any problems?
No, because they never got to use the fat client. So the fat client was only there, it was a work in progress. I'm just navigating through so you see some of this. The fat client was only there as a design tool for the in-house experts to convey business rules. It was never deployed.
Oh, I see.
So only a handful of users saw it. And when we did try, one of the issues with it was that.
Time for lunch.
There we go. Push the off button. One of the issues with it was that it didn't scale. We did try it to see if the fat client would go up. One of the things I didn't show you is I actually had it to the point where we thought the web interface would be a supplemental interface, and we'd have a fat client and a web use for most users, fat client for power users. Had it to the point where you'd be on the fat client, you push a button, and it would open a browser view of the view you were looking at the fat client logged in context. And then if you were on the browser, you could push a button, and the fat client would open a view on the thing you were looking at in the browser, kind of talking behind the scenes with OpenTalk between the images and stuff. It worked fine, but then when we tried to use the fat client with more than 20 people, it crashed and burned. It was just a very poor design that couldn't scale. So that was the decision point, recognizing that it wasn't going to go forward. We had this portal, this web portal, and I was like, well, this is not going to work, we better use this. And and that's the way it was. I mean, until you hit the problem, what's your motivation for changing it? They hit a problem, then they decided to change it.